In this video, we're going to look at the least you need to know about first-order linear differential equations. That topic is covered in section 1.3 in the text. First-order linear differential equations are differential equations that have this form or can be put in that form. Sometimes it's possible to do that. Many times it's not possible to do that. If it's not possible to put it in that form, then usually you'll try something else. Maybe your DE is separable, or maybe you can do something else, or you might just not be able to solve it at all analytically, in which case you would solve it numerically. As far as a procedure for solving first-order linear DEs, always make sure your DE is in first-order linear form. We'll look at a couple of examples where a little bit of rearranging is required. Then, if your DE is in first-order linear form, so you can identify the function p of x, the coefficient of y, then you can calculate the integrating factor using that formula, e to the integral p of x dx. We always leave off the plus c at this step. It's not wrong to include the plus c, but no one ever does that. This method is just a trick, and the trick still works if you leave off the plus c at this stage. So we always leave it off here. We will need to include a plus c later on in our solution, as you will see shortly. Once you have your integrating factor simplified as much as possible, you want to multiply the differential equation on both sides by the integrating factor. At that point, the left-hand side of the differential equation should be the derivative of a product. If it isn't, that tells you that you probably did not calculate the integrating factor correctly. So that's something you always want to check. If the left-hand side is the derivative of a product, then you can go ahead and integrate both sides, and the integral of a derivative of a product is just the product itself. And we'll see how this works in some examples shortly. At that point, you do need to include your plus c at that point, because you're almost done with your solution at that point. And you just solve for y as the last step. Example 1 is the first fairly simple example of a DE of this form that I recommend you try on your own following that procedure. And I would highly recommend you pause the video at this point and try it on your own first. A complete detailed solution is given on the next slide. So I recommend you pause the video at this point and try it. Hopefully at this point people have tried solving example 1 on their own. You're going to probably get more out of these videos if you will try things when I ask you to try them, rather than just going through the whole video. It will take you a little more time, but you'll probably a lot more learning will happen if you try things on your own as much as you can when I ask you to do that in these videos. Example 1 is given in first-order linear form already. We don't have to do any rearranging. P of x, the coefficient of y, is 6, and q of x is 8. So we are ready to go ahead and calculate our integrating factor, which is what's happening in this step. So our integrating factor is e to the 6x, and we leave off the plus c. Then we take our integrating factor and multiply both sides of the original differential equation by the integrating factor, which is what we see happening here in step 2. Notice that the expression on the left-hand side is indeed the derivative of a product. If you were to use the product rule on this expression, using the product rule for derivatives, you would get what we have right here. So that looks good. We're in good shape. It looks like we did calculate the correct integrating factor, so we're ready to go ahead on to step 3, which is to go ahead and integrate both sides with respect to x. On the left-hand side, the integral of the derivative of a product is just that product. For the integration on the right-hand side, in this example, we just have an easy integration by substitution. I left out the details on that, and you end up getting this for the integral on the right-hand side. And don't forget your plus c at that point, because we're almost done with the problem. Then we just, in the next step, step 4, we solve for y by dividing both sides by e to the 6x, or equivalently multiplying by e to the negative 6x. That gives us our general solution in explicit form. The next example is a little more complicated, and I recommend you try it on your own, following the same steps that I gave you as an outline at the beginning. Try example 2 on your own before you look at my solution. Good luck.